Welcome to Insight Builder channel, Large Language Model Automators, Python experts, and my dear friends. Introducing Django to Falcon 7 billion. Wiring up Falcon 7 billion model in the Django backend. Why to do this? We can learn how the loading of LLM happens when there is a GPU involved in the server. We can understand how to use the post method on the forms and get the information from the user. We will also store the data and retrieve it from the database after getting it from the users as well as from the model. So these three things we will be looking at how to do with Django framework, as well as we will work with the Falcon 7 billion model. How to do this? We have to build a web page with a form that can send a post request. This is pretty straightforward. We will see how to do that. This is something that I will show it you to begin with. Second, we have to research the transformers model loading process, because not everybody has a 24 GB or a 32 GB GPU, and the quantization process, bits and bytes library in Python has made it possible to run large language models in consumer grade GPUs. We'll be using that, and I'll be showing you the references on the models in this video. We have to write the views function that accepts the form data, stores them in the database, processes the inference on the model, and then returns the result. There will be two functions, one to render the page, render the form actually, the another to take the data from the form and process it. So there are two steps involved. HTML body of the form has to be written. I believe that you will like this video. Do leave a like, share it with others, subscribe to my channel for further updates on similar kind of videos that involve large language model, Python open source ecosystem, and the integrations of it. This is the page. This is the website that I've been building. The front end has been built using ChatGPT. You can take a look at the other video that I have posted on how this page was built. These pages, not just this page. And then this is the form that I am talking about. This is a model, the max length, the top K. These are all the additional information that we get from the user. This is the prompt that user can provide here, and this is the query. What is in the middle of the sun? So let's submit it. And the moment I submit it, the request goes to the server. Let me show what happens at the backend for you guys. So here we can see the request has been received. The request has reached the server, and you can see the model loading here. And once the model loads, it will take a couple of minutes. The model is already in my local machine, and that's why it is actually fast, or else it will take time. This is one of the key points you guys have to understand. The model has to be in the local server that you are using. Once the model pipeline is loaded, once the model processes the output, then you can see the reply from the server that it has completed. If there is a response from the server, not reply, response from the server, and the response is 200 if it is successful. You can see the output here. What's in the middle of the sun? Answer. The above question, thinking step by step. So the model follows the instruction and tries to come out with an answer. We can access the same query that you raised it a couple of minutes back, and then you can read it later also. So the query and the data is stored back in the database. I want to show you the additional information that the query store. So what is in the middle of the sun is the query that we sent, and here is all the information that got stored from the user. So from the post request that came from the form. We have seen that how the page looks. So the HTML body with the form capable of post request. So we have seen how it looks and how it works. We have also seen that the views function that accepts the form data, stores them in the database, processes the inference, etc. Now we are going to look at how it is coded. So before we go to that, I would like to direct you to this particular link, which I referred for using the Falcon 7 billion instruct 4-bit model. So this is the sharded model was provided by Wilson Rodriguez. Huge shout out to him and thanks to him for that. He explains the process very simply. The bits and bytes configuration is used for quantizing the model. Basically, quantization reduces the size of the parameters inside the model. If you guys are new to quantization or the AI model arena, I would suggest to look at my other videos in the playlists. You will be able to come up to speed in no time. Next, the model path is provided. This model path calls the Hugging Face hub, and from this location, so this is the location where the actual model is stored, and you can see it comes up to 26 GB of data. However, once the model is loaded, let me go back. So once the model is loaded, when I load this model using model ID, the model ID that you see here, and the quantization configuration, once it is loaded, the model loads at less than 6 GB of GPU memory usage. So the quantization works very effectively. Once the model is loaded, he shows about the model specifications, and then we have this transformers.pipeline. So this pipeline is required for actually making our life easier. You can actually use multiple steps of creating the tokenization, sending the tokens to the model, and then getting and decoding the tokens back. I mean, you can do a lot of stuff, but transformers pipelines makes it simple. And this data 296, that max length and top k, this data I am trying to get from the user. So rest of the things are constant, so I'm not allowing the user to mess with it. Also, you can also try to add number of return sequence to make it make the output look more natural. So once the pipeline is created, all you need to do is send a prompt to it, and you will see the output. The output will be as a list, and the first element of the list will be a dictionary, and that dictionary will have a key generated text, and that is what you have to use. This is what this is how the model is loaded, and how it is generating the text. This is the research part. How to write the views function and how to trigger it, that is what we will see next. The trigger function, etc., is already updated. I could actually show it to you in the Vim, but I felt that it's better I showed it in the GitHub repo itself. We are in the GitHub repo right now. You are looking at the views.py. This also, this particular repo, you can clone it directly, and the files and its locations will remain intact. So you don't need to worry about that. You can start using it right away. Only thing is that you have to have a GPU if you want to load this model. So let's continue. In case of views.py, the f underscore page, this is the page that loads this page without any input. So if I click on this link, it will load the page without any input, and it has the form and it has the query list. If I go back here, the query list is populated using this particular variable. Then that context is sent here, and using the DTL, this query list is created. Continuing further, here we see the AI underscore Falcon function, which has the entire process that I showed to you a couple of minutes back using the Jupyter Notebook. The same process is followed except this step. Here I'm using the request.post.get method to get the necessary data from the form that is created here. I will be showing you how to name the form in a couple of minutes. Before that, let us complete this function. This is where the model is loaded, and this is where the pipeline is created, and you see the pipeline done print statement, and the prompt template is created. The output is taken. After the output is returned by the pipeline, that is the Falcon 7 billion model pipeline, the output along with the various data that we gathered from the post request is stored into the user query object, and the user query object save is called, which saves the data to the database. This model user query is created from the models.py. In the context, we are sending the query back and the output, and this is where the context gets rendered. So this is how the functions are written. The next question is, in order to trigger these functions, we need the URLs. So this URLs.py, which is under app underscore 1, has this two paths. You see Falcon PG and Falcon path. This path will trigger the respective functions, f underscore page and a underscore Falcon. So when I trigger the Falcon path, a underscore Falcon function will be triggered, and the request will be taken, it will be processed, and the output will be sent. this is the falcon underscore page.html. This is the HTML page which renders this form. I want you guys to concentrate especially on this form building process. In the form, we use the method post and the action is URL Falcon. So this is the name of the URL that we are using here. You see the name here, this name will trigger this path and this path will trigger this function. So this is how the mechanism works in Django. Once this function, once this path is triggered, the post sends the data that is collected in this form to the server. These are the names that is provided to each of the input text boxes, and each of this name is what is referred here. This references, all these names are coming from this name. And once you have the appropriate data filled in and you click the submit, the post action starts and the AI underscore Falcon, this function gets triggered. This is how the actual model works. This is how the actual page works. Okay, the model working is different. So let me again show it to you guys, just to let me reduce this. Let's not make it more, and let's keep this one, and let us ask how the Django. Let's submit and let's give it some time. Let me also show you the CLI for you guys to understand what's going on, and it will take a moment. So the model loading process has started. So as I showed you in the beginning, now we know what are the things that is happening in the backend. The post request has been received. The model pipeline process has started, and you see that pipeline is done right now. The moment the pipeline is done, we will see the request complete. And once you get this post request complete, then let us go back to the browser and you must see the output here. You guys can actually ask a lot of questions to Falcon. It has been trained with lots of information and token. You can get this necessary details in the model card here. This is actually written by Wilson Rodriguez, but the actual model is here. So TII UAE. So this team had created the Falcon 7 billion. So you can take a look at that. I believe that you guys have understood right now the entire process of working with post, working with the transformer models itself using GPU. You saw the time it takes. In my case, I have a 12 GB GPU. If it is, even if it is 8 GB, it will work for sure. You can actually take a look at that also. Just to show you guys before we close this, let me go to the CLI for a moment. NVIDIA SMI. Here we can see the model. Once the model gets loaded, by default the model does not get unloaded. So you see this 5600 MB. This 5600 MB is actually the model that has been loaded into the NVIDIA graphics card, which is having 12 GB of that is 12,282 MB of VRAM. You can see the NVIDIA SMI here and the CUDA version. And also, you can see the NVIDIA GeForce symbol here. So I believe that you have understood the basics of working with the models, working with Django, and creating a website out of it. There's a lot of things we can do. So I'll be building this website slowly and steadily into a full-blown AI-related product. So till the next video and next update, do leave a like if you like this video and share it with others. Subscribe to my channel for further updates on similar kind of discussions. See you guys. Have a great time. Practice, 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 practice.